today we discuss about the autoencoders for dimensionally reduction. So dimension reduction is the important process in data cleaning in the feature engineering. Okay. So how autoencoders works and what are the different techniques are there? So we'll discuss. So autoencoders. What is autoencoders? So autoencoders are the type of artificial neural network used to learn efficient representations like encodings of input data, typically for dimensionality reduction or noise reduction. They are unsupervised learning models trained to reconstruct their own inputs. So autoencoders, this is used based on the neural network system. Okay. And we use the autoencoders to reduce the dimensions of our data and find out the important features or patterns, complex patterns from the data. Consist of encoders. What is the encoder? So compress the input into a latent space representations. So encoder works for the compress the input and decoders works for reconstruct the inputs from the latent representation parts. So whatever the compressed data, so compressed data is done by the encoder, and from this compressed data, reconstruct the original data is the work for the decoders. So these are the two components we use in autoencoders. Okay. So how it works? So the architecture. So whatever the input layer pass the data to encoder. Encoder convert that data into compressed form and pass to the bottleneck. So bottleneck is used to store or hold the compressed data, and from this bottleneck decoders get the input and convert this compressed data into reconstructed image. Okay, so this is the process for autoencoders. So bottleneck layer holds compressed representations and training aim to minimize the reconstruction error. So whatever the errors we have in our images or whatever the complex patterns we are trying to find out from the data. So with the help of this process, we can find this. Okay. Then reduce dimensionality. So there are different techniques to reduce the dimensionality of data. So an autoencoder is one of them. So it works on non-linear data and based on the high data driven. PCA is the one of the dimension reduction technique where it works on the linear data and it's interpretable and fast. UMAF is one of the dimension reduction technique which works on non-linear data and preserves global and local structures. These are the different techniques, and right now we are discussing about the autoencoders. So autoencoders offers a flexible method for dimension reduction. Okay, so it's a flexible. We can manage the structure as per our requirements. So work well on non-linear high dimensional data. Complements, so for traditional techniques like PCA and UMA. These are the some techniques where we can use for the dimension reduction. So types of autoencoders. So based on the data or based on the process, there are different types. So like basic autoencoders, which works on standard input and output match. Okay. Denoising autoencoder, it works to find out the data where the input is noisy, and with the help of autoencoder we can get the clean output. Sparse autoencoder encourages sparsity in latent space. Variational autoencoder, probabilistic latent space, it works on the probabilistic latent space. Convolutional autoencoder, so it works based on the CNN, so it's used for the images. Okay, and sequence autoencoder is the sequence, so it works for the series or time series or text. So it uses RNN and LSTM sparse. Okay, so these are the different types of the autoencoders we use based on the data and based on the process. So application where we can apply this autoencoder process, in which process? So in image compression, okay, anomaly detections, data denoising, feature extraction. These are the some applications or processes where we can apply this autoencoder to find out the complex patterns and uh, to reduce the dimensionality of our data. So some advantages of these autoencoders is capture complex non-linear patterns, customizable architecture. So it's a totally based on the neural network. So we can customize this architectures, scalable to large data sets. So based on the large data set, it works well. Okay, find out the complex patterns. So this is the technique we can use for the dimension reduction.